Oh, yeah, physics class.
Yeah, double class. But you know what I'll do? Let me think. We'll get this finished today. So that leaves us in a position where we have 3 maths finished and 3 physics finished. Next week I'm going to do a practice exam, which I'll give you tomorrow to do over the weekend for maths and physics. So I'll end up doing both of those next week. So I think I have enough time, just about, to do one more exam of maths or of physics.
How about to do a mock?
But that's what I'm doing next week, is the mock.
Really?
I'll give you a mock exam, final exam to do for the weekend, and I'll do it in class next week.
No, like, okay. Review this.
It'll save time if you do it at home as a practice rather than wasting class time to do it. I mean, I could do it in class if you wanted, if you feel that would benefit you, but I don't feel it would benefit you.
You absolutely do.
Well, because you know it will give us the practice and the time, you know, main time.
But I think it would be better if you can simulate the conditions at home rather than in class. I can give you a mock if you want. But anyways, I might have time to do one more maths or physics. So which would be preferred, maths or physics? Version 4? I think so. So tomorrow we'll do physics in the double class. I'll give you a new exam. Right.
Tomorrow we have math and physics.
What will happen?
Now you have a double class tomorrow,
Yeah.
and we'll make it a double physics. Then it's just it's 2 to 4, yeah.
2 to 4.
Yeah. And no, there's I have a meeting at 1. Yeah, 1 wouldn't work. All valid reasons. Yeah, lunch at 1. Look, we'll do physics tomorrow in the double. We'll try and get most of it done. Okay. Number 5 here.
Okay, that's good.
Right, so this one here, this is one of the topics from waves. You have a metal pipe and its length is 0.85 meters. And is it open at both ends or one end? Both ends. And it's at its fundamental frequency. So if you remember, that is a antinode at both ends. Isn't that right? No, sorry, no, wrong. It's hard to draw, but it's actually like an X. It's a quarter of a wave that fits in. Oh, ugly. Here is the node, and at the ends are antinodes, and here antinode. Huh? That's a quarter wave. I can see it's a quarter of a wavelength in there. What I was doing originally was half a wave, but I can fit a quarter in here.
Not half.
Half fits in as well, but the fundamental frequency is the smallest wave you can fit in. Yeah. So now, if you remember here, imagine you put some sand on the bottom of the pipe. Sand, yeah. There's sand here. So I cover the bottom of the pipe with sand. What will happen to the sand? So there's sand here in green. What happens? It'll move, yeah. So what will happen? No. Anybody? You forgot this. Where will it? How will I change my picture? So what will happen is the sand, which is located at the end of the pipe, will move because it's being hit by the antinode, which is maximal vibration. But the node is no vibration here, so the sand happily sits here. So what's going to happen is the sand is going to get pushed to the center, and you'll end up with a little bit of a pile of sand in the center. So if you were to look at the graph, where this is the X in meters, and this is how much sand you have, and this is 0.85. You'll have not much sand at the start, and then you have most of your sand in the middle. This is like a sand graph. Where is your sand? Sand is mostly in the middle. Now, I have a feeling I have basically done part 1, 2 and 3 together. Draw a further diagram to represent the amplitude of the particle displacement. There it is right there. I've done everything. Have a look at them. I know. No, don't believe me. That's okay. Don't believe me. They did what? Hang on, let's have a look at their answer scheme. No, part 3, they switched to second harmonic, that's all. So, yeah, that's why you drew half, because it changes. So this is actually the answer for part 1 and 2. Now on to part 3. Can I scroll down to part 3?
Yes, please.
Yeah.
So the only difference in part 3 is what? It's the second harmonic. So the second harmonic is this one. What's here? Node, node, and what's here? Antinode, antinode, antinode. So this time, if I put the sand in,
Yeah, this is fine.
We have to draw some.
I will just for fun. This is the sand. Where is the sand going to mostly be? Well, it'll be a little bit at the first node, and then none in the middle, so it's empty in the middle, and then a little bit more at the second node and none here. So this is 0.85 divided by 4. So this distance here is 0.21 meters. And this distance here is 0.43 meters. And this distance here is 0.64 meters. I don't even think he lists does he list the distances on the graph?
No.
No?
Isn't it that huge graph? You did
No.
any graph. But 3 graph.
He didn't actually, that's right, he didn't, and he should have, because it actually asked for a graph, not a diagram. Oh, well, that's for a diagram. Well, if that means my stupid diagram here would have been enough.
Yeah.
Depois de disso, são.
Huh?
Depois disso, são.
No, I'm using sand because, well, 1 for fun, but 2, that's how I explained it in the class. Because it just helps you visualize what they mean by the motion of the particles. Because you might say, well, there are no particles because it's a sound wave, and you might say, but the sound wave is the vibrating air. And then it's quite difficult to picture that. So what I say in class is, imagine that there's sand on the pipe, and the sound wave is hitting the sand. What would happen to the sand? It's how I explain this. Alright, part 4. Right, so this is, we'll just continue from the last part. How much of the wave does I fit into the pipe? Half a wavelength, wasn't it? In my picture, half a wavelength? No, is it half a wavelength? No, it's not half a wavelength. That is 1.5 wavelengths. No, 2. No, wait, that's a full wavelength. This wave here is 1 full wave, isn't it? Yeah, top, bottom, top. It's a cosine wave. It's 1 full wave. What do you mean, no, KJ? Is the answer in the book 400 hertz? 200. This is the problem. The problem is, in this question, there are two waves. The original fundamental wave, and now this new wave, second harmonic. And he says, what is the frequency? Which wave is he talking about? I don't know. Does he mean the original wave, or does he mean the one we just did?
So then the first one is half a wave, not quarter of the wave.
Is this one half a wave? Is that right? First question, is that diagram right, or did I draw it wrong? Do I have the wrong way? Can you show me? That's right.
Yeah.
Sam, the first diagram is half a wave, not quarter of the wave.
The first diagram is half a wave. That's right, yeah. The first diagram, I said a quarter, didn't I? But I actually drew a half. I drew half, or I said a quarter. Apologies. So it is a half a wave in my diagram here. Now, this is really bad. Really, really bad. I thought when I read this question, he was talking about the previous one. But in fact, I believe he's talking about the first one, the fundamental one. In the first diagram, how much of the wave was fit inside the pipe? Wakey, wakey. Half. So if half a wave is 0.85, how much is a full wave? Twice this. You have V equals lambda F. So F equals V over lambda, which will be 200. It's really, I cannot stress how bad it is that the question did not say which of the two waves he was talking about. I naturally thought it was the one right before this, but in fact it is the original one. Huh?
You need to change a lot of things. You need to change the other factors.
It's unfortunate. Now, in fairness, if you actually did do the one I was going to do, I would recommend that students who did that still get the marks, because the question is not clear on which two to use.
You will give us the marks too.
No, I would recommend it. I cannot give it to you, but I'll ask that it will be given to you.
But for example, if you want to check our example, right, firstly.
Yeah. I can't give you the marks, I have to follow the marking scheme. I can ask them to add it in later, and they can choose to or not to. Right, B part.
Can I add this down, please?
Yeah. Well, I'm not going to write anything for B part 1 because it's definitions we've seen before, but we'll just say them. Interference. What's interference between waves? Tumbleweed.
Can come on top of it, that cancel each other or intensify the...
You're thinking back to high school. Interference of waves is, when two waves come together to form a wave of greater or less amplitude, like you were saying. When they come together to form a greater wave, that's called constructive interference. And when they come together to form a wave of less amplitude, that's called destructive interference. Another definition is that interference of waves is the, I don't know which he gives, that's one valid definition. Another valid definition is the interference of waves is the superposition or combination of two waves, waves combined in a linear algebraic manner. So there's two definitions. The first definition is fine. What does he go for in the marking scheme? First one, okay.
That is really expressed in multiple of waves and...
Yeah.
This is that
Part 2, path difference. So path difference is the difference between the peaks of two coherent waves traveling together. Is it? No, sorry, that's phase difference, apologies. Path difference, I'll draw a diagram to help explain. You have, look here, source 1 source 2, and target. So you have one wave. So, for example, here is one wavelength, two wavelengths. So this wave travelled how much? Two wavelengths. And let's say this wave, one wavelength, two wavelengths, three wavelengths. This one travels three wavelengths. The path difference is one wavelength. So the path difference is the difference in the distance travelled by two coherent waves reaching the same target. KJ, what does he go for?
Consider distances from
Slow it down, man. Slow it down. What does he go for? Say it again.
consider the distances from two light sources of light to a point in the space. Difference between these two distances is equal to
Exactly what I said.
usually expressed as multiple movements.
Exactly what I'm saying. Okay. And lastly is phase difference. Phase difference is the distance between two coherent waves traveling together. So if you look here, coherent waves. What did I say? I thought I said coherent. Are you sure? Watch this video again. Hang on. You're looking at 16 minutes into this video. I'm pretty sure I said coherent. I want you to watch it and then comment on the video. Yeah.
But coherence is the third one, and we just did five different.
Oh, I'm sorry. You're saying I skipped the third one. No, I understand you. Coherent waves. Okay. What are coherent waves? Okay. Coherent waves? These are waves which have the same frequency and they must have the same frequency and oh my goodness, constant phase difference. Yeah, I was actually explaining what phase difference was when I thought you were saying something. Right. Coherent waves are two waves with the same frequency and constant phase difference. And finally, phase difference. So phase difference is the distance, the constant distance between the peaks of waves which are travelling together. So, let me draw it. So look, if you have this wave, and it's happily travelling to the right, and then you have this wave, and it's also happily travelling to the right, the phase difference is the distance between the peaks of the two waves travelling together. That's the phase difference. Is that okay, KJ? What does he say? Fraction of the wavelength, yeah. That's fine. Technically, you don't have to use the distance between the peaks. You could use the distance between any part of the wave. He's just being more general, but this is fine. Right, part C. Good old-fashioned Young's double slit. The wavelength of the light is 450 nanometers. The slit separation is 0.15 millimeters. The n is 3. And what's the theta? Is that it? N lambda equals d sine theta. What is the answer? I don't know. It's like half a degree. It's something really small.
Yes.
Lame. 0.516 degrees. What way did they do it? It's just they did use this formula, right?
They drew a triangle.
Wow. Talk about making life difficult. Right, let's have a look at the last one, 6. It's a graph question, so I'll open up the graph.